Here's a quick overview of what we will cover. We will cover Popper, the nature of science, paradigms versus positivism, within economics, instrumentalism, how many economists does it take to change a light bulb, application, a real-world walkthrough, summary, how the lecture fits together. We will start with the foundations, build step by step, and end by tying the ideas together. Science evolves through a process of making guesses and testing them. Over time, we refine our ideas but never reach complete truth. Put more directly, Popper's view suggests that scientific knowledge grows through conjectures and refutations, moving from myths to better scientific understanding. For example, consider how early humans believed in myths to explain natural phenomena, like thunder being a god's anger. As science developed, these myths were replaced by theories based on observation and experimentation. What this example shows is that this example illustrates that science progresses by replacing outdated myths with theories that can be tested and refined. Understanding this evolutionary nature of science helps us appreciate how scientific knowledge is built and why it is subject to change. Once that is clear, the next step is paradigms, because it develops the next piece of the same argument. A paradigm is a framework that guides how scientists view and interpret the world. It influences what they study and how they understand their findings. Put more directly, paradigms represent the shared beliefs and practices of a scientific community, dictating what constitutes normal science. For example, the shift from the geocentric model of the universe, where Earth was seen as the center, to the heliocentric model proposed by Copernicus illustrates a paradigm shift. What this example shows is that this example shows how a dominant paradigm can be challenged and replaced when new evidence arises that cannot be explained by the existing framework. Understanding paradigms is essential because they shape scientific inquiry and can hinder or facilitate scientific progress. Once that is clear, the next step is paradigm versus positivism, because it develops the next piece of the same argument. The paradigm approach emphasizes the importance of scientific frameworks, while positivism focuses on observable facts and empirical data. Put more directly, paradigms guide scientific inquiry, whereas positivism seeks to establish knowledge based solely on empirical evidence. For example, the Ptolemaic model of the universe relied on observations that fit its Earth-centric view, resisting challenges from Copernicus's heliocentric theory. What this example shows is that this example highlights how the Ptolemaic paradigm selectively interpreted observations to maintain its validity, demonstrating the limitations of a purely positivist approach. Understanding the contrast between paradigms and positivism is vital for recognizing how scientific theories develop and change over time. Once that is clear, the next step is within economics, instrumentalism, because it develops the next piece of the same argument. Instrumentalism in economics suggests that the value of a theory lies in its predictive power, regardless of how realistic its assumptions are. Put more directly, Friedman argues that the significance of a theory is determined by its ability to make accurate predictions, not the realism of its assumptions. For example, Friedman's view implies that even if economic models assume firms act as if they maximize profits, these models can still be useful if they accurately predict market behavior. What this example shows is that this example illustrates that the predictive success of a theory can justify its use, even if it is based on unrealistic assumptions. Recognizing instrumentalism is important because it highlights how economists defend their theories against critiques of realism. Once that is clear, the next step is, how many economists does it take to change a light bulb? Because it develops the next piece of the same argument. A humorous take on economics highlights the complexities and contradictions within the field, often using satire. Put more directly, this joke illustrates the various roles economists play in addressing market dynamics and structural changes. For example, the joke about economists changing a light bulb humorously suggests that multiple economists are needed to navigate the complexities of market forces and comparative advantage. What this example shows is that this example shows how economists often have to manage the consequences of their theories and policies in real-world scenarios. Understanding this humor can provide insight into the often complicated and sometimes contradictory nature of economic theory and practice. Once that is clear, we can pull the whole lecture together and see the full logic in one connected chain. Consider a simple hypothetical market facing a shock. A basic textbook model would usually isolate one variable and ask how the system returns to equilibrium. This lecture takes a different approach. It asks what happens when several forces move together, feedback on one another, and change the behavior of firms, households, or institutions over time. That is why the concepts in this lesson matter as a group. The application slide is where the theory becomes usable. It shows how the lecture helps explain a system that evolves instead of sitting still. This lecture builds in 3 moves. First, Popper, the nature of science. Paradigms define the problem and show why simple equilibrium thinking misses too much. Then, Paradigms versus Positivism explains the mechanism that actually drives change in the system. Finally, within economics, Instrumentalism and how many economists does it take to change a light bulb. Apply that logic to real competition and industry behavior. The full lesson is that once multiple variables interact, innovation matters, and firms respond dynamically. Economics has to explain process and feedback rather than assume the system settles down by itself.